Problem 7-64 from section 7.1.4. A 70-degree angle is drawn for you in the unit circle at the right. So they're saying this little angle in here is 70 degrees. Okay, approximate the coordinates of point R, which is down here. Now, we need to look, this problem is particular about how it's asking you to answer the question. We're talking about coordinates in both parts A and B, but part A is approximate, and part B says how do you find the exact ones. So approximate, I know the coordinate is going to be the cosine of my degree, and then sine of that. So I can approximate these by using decimals. So I'm going to take cosine of 70, and then sine of 70. And type those into my calculator, and those numbers get me roughly, so point R is about 0.34 is cosine of 70, and 0.93 is sine of 70. So that is my approximate coordinates for point R. That's using decimals, that's allowed. So part B says, how can we get the exact coordinates? Well, the exact coordinates just means, how can I not have decimals in there? So what we can do is we can just leave it with, so part B, we can just leave cosine of 70 is going to be my x-coordinate, and sine of 70 is going to be my y-coordinate. So there's our exact measurements, or exact coordinates of point R, just leaving it as cosine and sine. So part C says, show that the Pythagorean identity works for this angle. So the Pythagorean identity, we discovered this in class, it's like the Pythagorean theorem, but instead of using A, B, and C, we're going to say kind of cosine of our angle squared, so that's like side A squared plus side B squared, but to find the side we're using sine. So now that squared equals 1 squared, which is just 1. So I'm going to leave it just as 1 there. So they want us to prove that this works. So what we're going to do in our calculator, we're going to do cosine of 70, square it, cosine of 70, and square it. Now, what's going to happen is we don't want to round these. So the point of part B is to get us how can we use these coordinates as exact numbers. So we're not going to type in cosine of 70 as a decimal and then square it and round it, because then it really is not going to equal exactly 1. So what we're going to do is keep it as cosine of 70. So let's type in cosine of 70, and then we're going to square that, plus sine of 70. And hopefully, if this is true, it will equal 1. There we go. So as long as we're using our exact coordinates of point R, so we're not using decimal approximations, then we know that that is a true statement. So we can use the Pythagorean identity to prove the coordinates are exact.